We've talked about slope-intercept form, where you know the slope of a line and the y-intercept of that line. We've also talked about point-slope form, where you know the slope of the line and the coordinates of a particular point on the line. Another form of linear equation is the standard form, and this is the form that standard form takes. And standard form is really useful for a particular kind of problem that I'll show you right now. So let's say that Ollie has $10 to spend on lunch. Chips are $2 and sandwiches are $4. What combinations of items can Ollie buy? So one way that we can figure this out is we can make a simple table that shows the different combinations of chips and sandwiches that Ollie could buy. So if Ollie bought one bag of chips, that would cost $2, and so then Ollie would have $8 left over to spend on sandwiches. So he could buy 2 sandwiches with those $8. If Ollie bought 3 bags of chips, that would cost $6, and so then Ollie would have $4 left over to spend on a sandwich, and that would allow him to buy 1 sandwich. If Ollie bought 5 bags of chips, that would cost $10, and so Ollie would have no money left over to spend on sandwiches. So with this table, we could think of each of these numbers as the x and y values of the standard form of the equation. And if we were to generalize this situation into the standard form, this is what it would look like. We would write it as 2x plus 4y is equal to 10. Now 2 is the cost of 1 bag of chips, and then 4 is the cost of 1 sandwich, and 10 comes from the fact that Ollie has $10 total to spend. And so if we took one of these sets of values and substituted it in to this equation, then we could check whether or not this was a true statement. So if we choose this set right here, so 2 times 1, I'm just substituting in my x value right here for x, plus 4 times y, which is equal to 2 right here, that is equal to 10. And if we simplify, 2 times 1 is 2, plus 4 times 2 is 8. And we know that 2 plus 8 is equal to 10, and so that's a true statement. Now, it might not be immediately apparent how you would graph something in this form, 2x plus 4y is equal to 10. But just like how we converted slope-intercept to point-slope form and vice versa, we can do the same thing here. And so if we take the equation again, 2x plus 4y is equal to 10. If we want to put this into slope-intercept form, for example, all we need to do is isolate y on one side, on the left-hand side of the equation. So in order to do that, I'm going to subtract 2x from both sides. And then 2x subtract 2x is going to be equal to 0, so I'm left with just 4y on the left-hand side. And then on the right-hand side, I have negative 2x plus 10. And then in order to remove the 4 on this side, I'm going to divide by 4, divide each of the terms by 4, and that's going to give me y is equal to negative 1 half x plus 10 over 4, which simplifies to 2.5. And we can graph this line now that it's in slope-intercept form. I'll put a little square around it. We can graph that line in slope-intercept form, and I'll put a graph right here. And I'm going to put 3 hash marks on my y-axis. 1, 2, 3. And then on my x-axis, I'll put 5. 1, 2, 3, 4, 5. And then I'm going to change colors here so it stands out from the background a little bit. So to graph this slope-intercept form of the equation, I know that my y-intercept is 2.5 right there. And so I'm going to find 2.5 on my y-axis. And then my slope is -1/2. And so for every step down I take, I'm going to take 2 steps over. So if I go down 1 and over 2, that's going to be my next point right there. And then if I go down 1 again and over 2, that will be another point. And then finally, if I go down 1 again and over 2, it'll be about right there. And so here I have a line, and let's see if I can connect these dots. I'll see how well I did. Pretty good. So I can connect those dots with my line here. And this is the line that models this equation right here, but also this equation right here, because it's just in a different form. And so if I check with the table that we made in the very beginning, I can find 1 on the x-axis, so that's right here, and then you can see that that corresponds with 2 on the y-axis. So in other words, if Ollie buys 1 bag of chips, he's going to be able to afford 2 sandwiches. Similarly, if Ollie buys 3 bags of chips, she can find 3 on the x-axis, then that's going to correspond to 1 on the y-axis, right there. And then finally, if Ollie buys 5 bags of chips, that's going to be all his money. He's not going to have any money left over for sandwiches, so that's going to be our x-intercept right there. And with these sorts of problems, one thing that's handy to do is to label the y-axis and the x-axis. So obviously this is our y-axis, but it's also the number of sandwiches that Ollie can buy. So I'll write sandwiches right here. And then our x-axis right here is the number of bags of chips that Ollie can buy. And so I'll write chips over here. A little messy, but you get the idea. So again, we had the standard form of this equation where we had 2 values that were changing simultaneously to produce a third constant value. So those values were the number of chips that Ollie bought and the number of sandwiches that he bought. And as you can see from the line here, the more chips Ollie buys, the less sandwiches he can afford, and vice versa.